Today in this video, we're going to dig into three variations of the Log4j exploit, three payloads and different sophistication levels of actors that we've seen, as well as three different log sources and the analytics that you can use for this detection. So today we're also releasing our own damn vulnerable web app that's based on Log4j, where we're going to use in this video to exploit it multiple different ways. In that GitHub repository, we're going to release all of the raw logs showing the various different exploits and the forensic evidence that's left behind. Okay, so this is a great diagram put up by the Swiss cert that kind of explains all of the steps for the attack. So it's important to understand which pieces of this we have control over and how that fits into our lab scenario. While there's really 5 steps to this exploit, really there's only 2 hosts that are really a major player in this. There's the attacker machine and then the victim machine. The attacker, we're going to use 10.0.0.6, which is a Kali image, and the Windows victim is running our damn vulnerable Log4j app, which is Tomcat web server. As you can see, the attacker is going to launch the attack in step 1 with a curl statement typically. It's going to then call back, the Log4j exploit is then going to call back to the attacker machine, pick up a payload, and then call back to the attacker machine to pull down some malicious Java code. So that's basically how the exploit works. So with that in mind, let's jump into the 3 examples that we're going to dig into. Okay, so 3 exploits, 3 payloads, 3 detections, increasing in difficulty. So first up is Huntress Labs produced Log4Shell, and this is a great tool to test various different applications without using any of your own infrastructure to see if there's some vulnerabilities in the user input. So we're going to dive into that and show you that. Next up, we're going to take it up a notch and get some remote code execution through popping calc on a very standard exploit using against the user agent string. And then the last, we're going to jump into exploiting a post variable with some obfuscated exploit as well as a encoded reverse shell. So this is a bit more realistic, a bit harder to detect. Okay, first thing we're going to do is we're going to set up our environment. What I'm going to do is I'm going to start up a capture tool. This is a internal tool we use to capture attacks. So it's going to capture the Windows event logs, the sysmon logs, the Zeek logs, and PCAPs. And it's going to also capture the screen. So that way we can see both what the hacker's doing on the Kali image as well as what's happening on the logs on the Windows system. And it'll just help us analyze the second and third more complicated attacks. The second thing I'm going to do is I'm going to cd into the bin directory and I'm going to start up our Tomcat server. So this is that damn vulnerable web application that we released on GitHub. You can download this and run it if you want to see the exploit and test your detections against this as well. And with that, let's just talk a little bit about Huntress Log4Shell vulnerability tester. So you can browse to log4shell.huntress.com. And like I said, this is a way to test device input for vulnerabilities to this JNDI exploit without having infrastructure. And there's a really great how-to page here, but basically when you browse there, you get a randomized string every time you browse to the site, and that is your exploit and what you throw into the user-controlled input of what you want to test. After that, you can view the connections, and they explain down here in the technical details. There's no actual malicious code being run on your system. Basically, it's just they're running the LDAP server, and if your vulnerable host actually calls out to their LDAP, they're going to let you know and then terminate that connection. All right, so with that, let's use this for our first exploit. Here's our damn vulnerable app. We're going to exploit the get string. So there's a user agent string, a get string, a post. Typically how this app is working is it's looking for a get string, and this is where we're going to throw the exploit. So if we were to just paste that exploit right in, this is essentially what we want to do. So I'll hit the enter and I'll show you it's not going to work. It's a 400 request because this has some special characters. So we need to use URL encode, and we will encode this payload into a URL friendly version. All right, so now let's go back there and let's replace those special characters with a URL encoded version. So when I hit the enter key, if it works, yes, it did. Okay, so it's going to show me what I sent it. And then what you can do is you can actually go back to Huntress's site and say view connections. And if this was a vulnerable app and the exploit worked, what's going to happen is it's not it's going to show up here as the callback address. So this is this IP address. This is my victim host reaching out to Huntress, just doing a DNS request and doing that first stage call out. They're not doing anything malicious. So this is a great non-invasive way to test out the exploit and see if your app is vulnerable. And of course, you could spray this in many different user-defined field inputs, and then check back here to see if it's vulnerable. Okay, so let's talk about detection for this. So Huntress does not do the full exploit and payload and things like that, but that doesn't mean that there's no forensic evidence left behind in certain cases. So, for this very basic case, we were exploiting the get parameter, if you recall. So get parameters by default for web servers are stored in the access logs. So let's open up the root directory for Apache Tomcat. And let's go into the logs directory. Here's the latest access log, and let's open that up. All right, so here's very standard web logs going on, and if we scroll down, we have our exploit logs. So here you can see our get string calling out the JNDI log shell to Huntress. So you can see that this is the exploit string that we're going to be looking for. We're going to go more into depth about this string and some obfuscation options in the future. But I just wanted to point out a very simple detection for web access logs or hunting through them. If it happens to be in the get parameter, then this is a good place to look. Unfortunately, our next two exploits are not going to be as easy, so we're going to have some more advanced detections for them. But web access logs is one of the first places you can start hunting for some evidence of this exploit. With that, let's jump into phase two. Phase two, we're going to need some infrastructure. Okay, so if you recall, our goal for phase two is we are going to exploit the user agent string of a web server, and we are going to get code execution and pop-up calculator. So in order to do that, we're going to need some sort of an exploit kit. So we have, we're going to use for this specific one, we're going to use this one. This is a popular one, Python Log4RCE. The link will be in the show notes. And what this allows us to do is two things. One is it's going to run an HTTP server that's hosting up a malicious Java class for our call out to download and execute. And then it's going to actually be listening for a malicious LDAP server also. So when we trigger this, the JDNI is going to reach out to this LDAP server, and then that's going to push down a second stage, and then that stage is going to then call out for this Java class, malicious Java class. Because there's some infrastructure involved, if you remember back on the first one, we started our capture tool. So this capture tool has already been running. I just did the exploit, and it's best to review the logs and the video in SnapAttack. So let's take a look at what that would look like. Okay, so here we are. Quick introduction. We have the title, the author, some show note descriptions of the three phases that are captured for the attack here that we mentioned, some threat intelligence and external links, MITRE attack tags, and then we get to the video. All right, so now we're caught up. This red star, these are the three phases. Red stars denote major attacks that are occurring in the video. So here is the first one that we did with Huntress. So that should look very familiar to you. So let's fast forward the video to right here. So we're going to push pause right before the attack occurs. We will switch over to the Kali image. Okay, let's give a quick tour. So we have two victims in play, or two hosts in play, right? We have our Windows 10 victim that is running the web server, the Tomcat web server, and then we have our Kali host. So this is our attack host, and we have two windows in here. Let's zoom in and see what's going on. So in this window right here, so this host is 10.0.0.6. Our Tomcat server is .5. So here what we're doing is we're looking at the two windows. Exploit server is running on the left, and it's listening on two ports. The first port that it's going to listen for is on the HTTP, and that's to serve up our Java class, our malicious Java class. And then the other port, 1387, is going to be listening the malicious LDAP server. Okay, so first stage callback is going to go to 1387. Second exploit is going to go to 1337. Over here, we're going to trigger the exploit, and unlike the last one where we triggered it via a get HTTP request, we're going to trigger it here using a user agent string. So the tac a in curl means pass this string to the user agent, and you'll see that it's a very similar trigger. But what's changing is instead of the callback being Huntress Labs in the last one, it's going to be our server at .6, and we're gonna serve up the rest of the exploit here. So let's see what happens. We're going to push play. You very quickly see the callbacks happening, right? So you see the LDAP query first, and then you see an HTTP query. So let's get out of this and see how it looks on the Windows side. So we switch over here, and sure enough, calc popped up, right as we were doing that. Okay, so let's talk about detecting this. So obviously we were talking about during the exploit phase that it's traversing the network, right? So it's reaching out to that malicious LDAP server and then again out to the HTTP server to download the malicious Java code. So if we take a look at it, the red star means there's an attack right there at the video marker, and the blue analytics, if we were to hover over them, they'll tell us there's some detections. There's multiple detections. We're going to focus in at 1 minute and 54 seconds, minute 52. We see this Log4 CVE analytic. So let's open that one. And here it is in the platform, but the source of this is Sigma, right? Sigma is an amazing community. It's over 1,800 analytics that are all open source and free to use. It's detection as code, meaning that this, in its current state, needs to go through a compilation process, and then it can be applied to Splunk or QRadar, Elastic, CrowdStrike, right? Various different SIM, EDR, different log sources. So this is discussing various different keywords for this JDNI and various different iterations. We're going to talk more about the iterations and the obfuscations in part 3, but for right now, this is the source for the detection rule. It's in the platform, and so it is hitting here. Okay, we're going to compile this down to Splunk. All right, so here is the code that we can run in our environment. So let's copy and paste this into our, we're seeing some Zeek logs hitting here. Okay, so let's dig in. So here is 10.0.0.5 as the host, and here's the exploit strings reaching out to .6. So if you remember, the .6 was the Windows victim right here. So that packet that we were looking at was this number 1 bubble. So attacker to Windows 10 victim, the initial exploit. If we were to dig into PCAP, we pulled up Wireshark and we dug into bubbles 3 and 5 are also observable from the network. So let me see if I can zoom in here. So on the far left is the exploit. Far left is the exploit. You can see this user agent string, the JNDI. Over here, you can see the bubble number 3 to the malicious LDAP server, and the last one over here is bubble number 5, which is when the Windows 10 victim is calling out to the attacker to pull down the HTTP Java class, malicious Java class. And so in the Java class, you'll see our command cmd.exe/calc. So clearly there's a lot of fingerprintable things across the network that we can look for. I'd suggest pulling down, I've seen some suricata rules as well as some snort rules looking at the network side of things if you have deep packet inspection at your fingertips. Okay, so that wraps up phase number 2, where we were looking more at the network side of things. Let's turn our attention to number 3. So number 3 was the more advanced one, right? So we have this, we're going to execute the web server via a post field in the HTTP. We are going to have obfuscated JNDI exploit string, as well as we're going to get full remote code execution and pop a reverse PowerShell back to our victim so that we have full control over the victim and can execute any kind of payloads we want to from that point forward. All right, so with that, let's jump in. Let's go back to SnapAttack. So here's our pre-captured SnapAttack session. You'll see, here's the first one, the Huntress. Here's the second one that we did, which was the user agent string across the network. This one has a lot more flurry of activity, and that's because it's at the end point. So we're stomping on quite a few more logs. Let's pause it right before the exploit. We'll switch over to our Kali box. Let's zoom in and take a look at what we got. So from the last one, this should look very familiar. This is going to be our malicious server. We're still using log4RCE, but the payload changed. So it was cmd.exe popping calc. We've changed that out to PowerShell with an encoded PowerShell encoded blob, base64 blob. So to get that, you can just use tools like reverse shell generator. I actually just found this yesterday. It's pretty cool. You basically tell it the IP and port you want to get a callback on. It'll tell you, a couple of different listeners that you can do, netcat, poemcat, socat, and it'll give you the syntax up here. So that's kind of nice. And yeah, there's different variations of this, of PowerShell callbacks. So you can pick your favorite. Since we're going across network, base64 encoding is kind of just a little bit more elegant. So you can just copy that, paste that in as your payload that you want to execute. And now we're listening on both our LDAP and our HTTP serve up port. Over here, we're going to exploit via curl once again, but instead of TAC capital A, which was user agent string, we're going to put the string in the TACD, which is putting in the data blob into a post message across HTTP. And as you can see, it's a little bit more difficult this time. Foo is the variable that we are exploiting, and the string is this JNDI, and then the LDAP string we saw before. But you can see that it's obfuscating the most fingerprintable part of the exploit. So we're going to have some different detections for this and some variations that we'll talk about. All right, so let's push play on this. And what we should see is our callback. Yep, we get our callback to the LDAP port, and we're serving up the exploit.class Java. And so if we continue to push play, you'll notice that I forgot to pop a third window. So I kind of quickly hurry up and set up my netcat listener. And sure enough, I do get a callback, which is good. So type in who am I, and waiting for the Windows server. Okay, so I'm Bob, PWD. All right, so yep, so you can see that we exploited. We have a netcat, like a reverse shell in Tomcat bin directory, which is where the Java runs out of, so that makes a lot of sense. Let's pivot over, let's get out of full screen. Let's go back over to the Windows host. Let's dig into some detections at the endpoint for this scenario. So at the end of a successful Log4j exploit, the attacker has the code execution on your vulnerable host. So that's the bad news. But the good news is that this does open up our more standard post-breach detection analytics, and it puts many people on more familiar territory to detect and hunt for malicious actors and actions in their network. So for this, we're going to use some EDR telemetry data, and that's usually our best go-to source for detection at the endpoints, although PowerShell v5 logging and some file system audit logs or even Windows Event 4688 command lines could also be very useful in determining if any exploit and hacker succeeded in exploiting. In this scenario here, we gained a reverse PowerShell. So the first detection technique that I would do is I would look for parent-child relationships of Java or suspected vulnerable applications. So we're going to scroll down. We will go to the Windows side of things. So you can see a flurry of activities. In the SnapAttack app, you can actually label. So the red team are actually labeled that there is an initial access Log4j post exploit that happened. There was a reverse PowerShell callback at that time, and then there was some discovery MITRE attack T10 or T1033, like system owner discovery running who am I. So this is kind of the red teamer's way of letting us know that these actions happened. And so the blue teamer kind of can come in here and analyze the logs that are happening. So let's do that. So I'm going to pause it right at that first intersection of an exploit. Let me pause it. And then I am going to jump into the process logs right around that time. So as this graph is loading, it's running all the analytics. This data comes from Sysmon, and this data is freely available on our GitHub post. It's just a way of visualizing Sysmon process data. So here you can see there's a bunch of maliciousness. The first PowerShell right here. Well, I guess we should back up. So here is the Java. So Java right here running the JDK, right, running it out of the Apache Tomcat directory. So these are some of the Splunk logs here. So this is our Tomcat. This is the spawn children. So you can see there's quite a bit of activity of PowerShell. Our first one, PowerShell. Yep, this is our PowerShell Tech E. So Tech E is encoded, which expects a base64 blob that it's going to execute. And so here is our execution of our reverse PowerShell callback. So if I wanted to dig into this PowerShell, let's see if I want to open this up in Splunk. Okay, let's see. Yep, here is the PowerShell. So I'm going to copy this out. Let's see right there. I will pop over to my CyberChef, paste that in, and sure enough, I can analyze the code that's underneath. And yep, it's opening a TCP socket back to .6 on port 88, and yep, it is redirecting standard in, standard out, back from PowerShell back over this TCP socket to Netcat, where the attacker is listening and able to execute arbitrary commands. Okay, now we've confirmed the base64 is definitely malicious. Let's keep analyzing the parent-child relationships. In this case, I see it running whoami and calc.exe, which is what we did during our attack. So, first step for detection is parent-child relationships. The second one would be, obviously PowerShell encoded commands or other ways of getting reverse shell or code execution is critical. Okay, so just to recap, we've gone through three different exploits, three different payloads, three different detections, right? So as for review, the first one was that Log4Shell by Huntress, where we used no infrastructure and we were able to test. Our detection method was Apache logs, Tomcat Apache logs, access logs. The second one, we did the very prototypical classic, I guess, if there is such a thing, Log4j exploit, where we used the JNDI exploit kit from a Kali box, and we popped a calculator, and we analyzed those logs, mostly around the network side of things. And then in the last exploit that we just finished up, we took a look at the remote code execution possibilities, popping a reverse shell from exploiting a post field in a web server. And we also tried to obfuscate that, right, with the JNDI and some obfuscated text fields to make it harder to detect. So I hope you've enjoyed this. This is getting longer than I expected. It's probably a lot more material that we could cover. But just to wrap it up, I'd like to say thank you for sticking with it if you're here. And if you're interested in more information around SnapAttack, go to our website. We actually are having a community open beta Q1 of next year. And our goal is really to bring a platform for red teamers and blue teamers to get together in the same platform, to look at the same logs and write the same detections and share threat intelligence. During the past week, we actually contributed to a couple of PRs, fixing some logic flaws or some gaps in coverage as we found them as we were taking community analytics and bashing them up against our true positives in the SnapAttack platform. Before signing off, I'd like to take my hat off to the security community, the researchers, the blue teams that have been putting in the extra hours this past week, especially those that were sharing the threat intelligence from the field. Nothing shows us how strong our InfoSec community is, like when these Log4j type crises happen. There's so much great research out there. It would be impossible to give proper credit to everyone, but I would love to acknowledge a couple and point you towards a couple of additional resources. So I'll put some links down in the show notes below. First up would be the Sigma community. Over 1,800 analytics, daily contributions, very active, engaged environment over there. Also, during the recording, or actually the editing of this video, we've been following the Surge team's work and the research they've been doing over there. And we noticed just actually yesterday after we recorded this, they put out an excellent video, very similar approach to ours. So if you like this video, definitely check them out next. They leverage the Log4Shell vulnerable Docker app as opposed to the Tomcat server we developed, and they use the JNDI exploit kit as opposed to the RCE. But otherwise, very similar approach, so definitely check them out. Also, I'd like to give out a shout out to John Hammond, Kyle over at Huntress Labs. They really epitomize the community threat research sharing that we strive for. and they were one of the early companies out there putting out actionable information. Lastly, check out our GitHub server, Damn Vulnerable Tomcat server, if you'd like to emulate these attacks and see what the vulnerabilities are and what the logs look like in your network. As well as don't forget to sign up for our public mailing list on our website for the public beta release of our SnapAttack. Thanks again. I hope you like and subscribe this video, and we'll see you on the next video.